see the screen.
Yeah, I get started now.
Okay, we'll be out of your way then. I mean, you are good to go.
Wonderful. Well, thank you all for joining. We are here to run this session on building, optimizing, and scaling AI agents on the cloud. Uh, Here we have myself, Anurag Bhagat. My name is Anurag Bhagat. I'm a senior strategist with what's called Gen AI Innovation Center at AWS. Along with me, I have Hannah. Introduce yourself, Hannah.
Sure. Yeah. I'm Hannah Marlowe. Great to be here today, and thanks everyone for joining. I'm a senior manager for model customization within our Generative AI Innovation Center.
In this session today, I think we'll talk about practical approaches to balancing accuracy, latency, and cost while scaling agent architectures on the cloud. We'll start by discussing what are agents, just to level set the definition. We'll talk about why they're becoming more and more mainstream. At the same time, we'll talk about, even though they're becoming more mainstream, there's still a lot of challenges with agentic systems. We'll discuss those briefly. We'll talk about orchestrating multi-agent systems. We'll talk about optimizing data deployments on production environments and on the cloud. Towards the tail end, we'll talk about real examples of a multi-agent system and a demonstration using Amazon Bedrock to show how these various pieces could fit together in actual practice and in reality. Quick brief on our team within AWS. We are part of a team called the Gen AI Innovation Center. We are a team of strategists and science people. We have data scientists, machine learning experts, deep learning experts. Our mission as a team is to help customers design useful solutions quickly at scale for our customers. We pair our science and strategy experts with the customers in a very mechanized process. Our goal is to help customers launch generative AI into production in a very risk-free fashion. And our goal is to see Gen AI applications get to prod as soon as possible. We do that in multiple ways. We provide hands-on keyboard support to our customers. We also provide advisory guidance for the right use cases. Just talking about generative AI overall, I mean, I think we all know the story, but just to level set, generative AI has evolved quite a lot in the last few years. It's relatively new, but it's still evolving very, very fast. 2023 was the year of proof of concepts. From that, we saw 2024. As we work with lots of customers, we saw a lot of these POCs getting into production. We heard lots of noises around, hey, it's in prod, that's good, but when are we going to see value? So in 2025, we've seen customers focus a lot on delivering business value, at the same time maintaining concerns of security, privacy, responsibility at the same time. What has happened in parallel, along with generative AI progressing from POCs to production and value, is we've seen a very rapid evolution of agentic AI. In the very beginning, we had seen agentic AI being used in very simple assistant kind of applications. Which used a simple set of rules, which were trying to automate very simple repetitive tasks. But that has progressed very fast and very rapidly. Now, what we are seeing at this point today is generative AI agents. We are moving towards a fully agentic world, which is intelligent. We will see multi-agent systems making complex decisions and coordinating effortlessly with less and less human oversight, which could possibly transform the way we work and innovate. And we expect to see this happening over the next few years. We're still probably midway into the journey. We'll see a lot happening over the next 3 years. But the whole point is we're seeing a lot of evolution in this space, and the amount of agency we are seeing is increasing day by day with agentic AI. Now, just level setting what agents are, because there's lots of definitions out in the industry. I want to make sure we level set on that. The way we describe agents are they are autonomous systems that can plan, reason, and complete multi-step tasks on behalf of humans. Now, how to do that? They break down high-level objectives into executable tasks, what we call planning, or some version of that. In terms of actually accomplishing tasks, what they do is they use tools, information made available to them, what are actions. From then, what they do is they're actually also capable of observing the results and updating the plan. This is actually fairly important because we don't want them to be deterministic processes. We want agents to be able to look at their environment, observe what's happening, and adapt to what's happening. So three keywords: plan, act, reason. An example of this could be, instead of just answering questions about available meeting rooms, an AI agent could actually access your calendar, check people's availabilities, send out invites, book a meeting room. Once that happens, you might see some declines. It may actually come back to you and ask, hey, is this person crucial? Is this optional? And based on that, it may actually revise the invite and do that over and over again. Now, we'll quickly talk about why agentic AI is at the cusp of a large amount of adoption, why it's becoming ready for enterprise adoption today. First of all, we've seen a dramatic improvement in the reasoning capabilities and reliable tool execution for models. We see a lot of reasoning models at the top of the LLM leaderboards. This capability, combined with their ability to process unstructured data, unlocks new areas that we were not able to automate earlier. Secondly, and really important for enterprise adoption, the economics for automation have shifted a lot. We've seen a 10x or even larger reduction in cost per token for frontier model performance, which makes the business case for using agents much feasible. At the same time, we talked about in the past how agents need to look at the environment and evolving requirements and do updates. This was earlier a blocker in earlier approaches. This adaptive planning and reasoning, along with the price performance that we see today with the models, allows for a more robust workflow automation and higher ROI. All these things combined together are leading to Gen AI use cases evolving from outputs to outcomes with agentic AI. All that put together, what we see is some projections which are talking a lot about using agentic AI. This statistic by Gartner talks about how in about 3 years, 15% of all daily work decisions will be made by AI agents, which is huge. Now, one thing to be really aware of is agentic AI is not really a magic wand. And just because everybody is developing agentic AI applications, it doesn't mean it fits every single use case. You have to be really careful about when to use agents, when not to use agents. One key advice we see based on our experience with customers is you should start simple. You should use traditional workflows for predictable tasks. If it's a very clear workflow with like no decision making required, you should not use agents. You should use agents for complex, unpredictable scenarios where you actually want the model to be able to reason and think through stuff. So the kind of best use cases for agents are tasks which require flexibility, adaptability, tasks which might require a multi-step reasoning process. You might have to do a dynamic tool selection where the solution itself might not be predefined. As you do that, some key considerations for agentic AI, which are very similar to what you see with LLMs in general. You have latency, you've got cost. At the same time, you have to think about task complexity and whether or not you need to adjust your workflow mid-task. As you build agentic applications, you've got to be there's a lot of trade-offs between latency, cost, and task performance, which are really important for agentic AI. And these are, again, not very different from what you see for traditional LLMs, but these have different flavor given the complexity of agentic AI. Accuracy, as we all know, LLMs tend to hallucinate once in a while. But as you have multiple LLM steps chained together into an agentic AI application, those hallucinations could tend to compound, and hence accuracy becomes a bigger challenge for agentic AI. Same thing for cost. A simple LLM inference could cost you a certain amount of money, certain number of tokens, but as you have multiple things chained together, you could rapidly have lots of tokens being used for a single call. and hence cost becomes a bigger constraint. Same thing for latency, because you have multiple LLM calls. Latency could become a big challenge. And hence, when you're designing agentic workflows, there are multiple optimization constraints, considerations to be balanced. At the core of these is the choice of language models, which has a fundamental trade-off between performance, cost, and latency. Smaller and faster models tend to reduce your operational cost and be faster, but they do, of course, sacrifice in quality and reliability of outputs, which is a challenge as we compound errors. There are a few ways we could actually try and work around that. There's a few I would talk about. Number one, what you should probably do is use smaller, more efficient models to handle simple routing decisions or initial classification tasks, while use bigger reasoning models for more complex reasoning, in-depth analysis, or multi-step planning. This hybrid approach allows for more optimal resource allocation while maintaining quality when it matters most. That's one. Second thing we've seen a lot that works well for customers is implementing progressive enhancement techniques and escalation paths, which enables workflows to start with faster, lightweight processing and escalate to more sophisticated models only when needed, not for every single scenario. What we've also seen is using model fine-tuning could really reduce your latency and inference costs while maintaining quality. And Hannah will talk about that in a little bit. Fundamentally, what you need when you're thinking about these applications is a very good evaluation system, which does not look through the entire application alone, but is tailored for agentic applications. You should be able to evaluate performance at every single step of your process. You should be able to support multiple test runs to account for randomness. You should be able to do all of that. You should be able to evaluate your tool call arguments, tool results, final answer, as well as adherence to the agent's original plan. As we build more and more AI agents, we've seen customers face a lot of challenges. We've seen development teams struggle with complex technology stacks and infrastructure setup. Operationally, managing multiple agents and orchestrating complex workflows is extremely challenging. Security and control requirements add one more layer of complexity, think governance needs and compliance requirements. At the same time, as we've all seen, the rapidly evolving technology landscape, we see new things emerge every single day, makes it hard to stay current while maintaining production systems. And this is where Amazon's Bedrock platform comes into play. For developers, AWS is providing the most comprehensive toolset that empowers users of all abilities to create, deploy, manage, and scale high-performing AI agents with ease. You could be using fully managed agents, or you could be creating your own DIY agents with Amazon Bedrock. You've got the model choice, you've got Bedrock agents, you've got Bedrock workflows, you've got multi-agent collaboration. As I said earlier, the choice of models is extremely important for agentic applications. Amazon allows you a huge choice of models for building applications. You've got models from AI21 Labs, from Amazon, from Anthropic, from Meta. We recently got access to Anthropic Cloud models, Opus 4 and Sonnet 4, which got released just last week on Amazon. At the same time, we've got hundreds of publicly available models through the marketplace as well. At this point, I'll go back to Hannah. Hannah, over to you.
Thanks. All right, let me see if I can take over and share. Just a minute here. I'm gonna take over. I'm gonna take over and share, and then I'm also gonna switch midway through, and I'm gonna make Anurag very nervous by doing a live demo where I showed it to him earlier today and it immediately broke. So everybody bear with me here a bit. All right, it looks like I'm doing my other view, right? Can you see my PowerPoint or the presenter view?
The latter.
Okay, hold on. All right, I'll try this one more time, and then if it does the same thing. How's that? Is that better? Great.
Yeah. Sorry.
Okay, so I'm going to talk through a little bit in terms of the optimization side and actually putting this into practice. So like I said, I'm going to do a live demo here, so that's kind of more of the tutorial part. And I'm just going to walk through a little bit more context of what we're going to show there. So just going back to the piece that Anurag mentioned earlier in terms of what are we looking at when we're talking about optimizing, a lot of it goes back to that cost, latency, and performance or kind of capability outcome. And that's really important when we're looking at agent workflows is, if you can run something in production with, you could probably grab a super performant, really large model off the shelf. But that's not going to really optimize in terms of your cost and latency kind of elements. So you want a solution that kind of gets at all of those. And sometimes it's a mixture, which we'll talk about in kind of the multi-agent approach. Some other capabilities that are really helpful to get to more, just optimization that you can kind of pick up and leverage pretty easily. One is model distillation approaches. So a really simple version of this can be like a distillation where you leverage a teacher model that's able to provide outputs that you then use to fine-tune a student model. And that approach can work really well, especially for applications like Q&A with a retrieval augmented generation kind of a setup. Also using intelligent prompt routing strategies to send queries to smaller, faster, cheaper models that can help save a lot of costs as well as latency. And then things like prompt caching can really be big wins. And these are things that I think we should expect to kind of get better over time as we have more of these systems in place, we'll find more ways to optimize. But getting to that model choice and being able to model right size is something that we see with a lot of customers that we work with. In terms of the agent workflows and building blocks, I think we've also seen, as I think the panel before ours and Anurag talked about a lot, this space is evolving so quickly. I think we're seeing a lot of people having to roll their own stuff, kind of build their own solutions, that now we're finally seeing some of the foundations and places from our side on the AWS side come in and help remove some of that undifferentiated heavy lifting that's not really adding to what you're building as much as things like memory management and session handling and security and guardrails and all those pieces. And so that's where the Bedrock platform can really come in and help give you an easier place to kind of build these things where you can focus more on the use case that you're building, the agents that you're leveraging, and less about, kind of all of the orchestration and management and updating and things like that. So by the way, I know the last session was very focused on MCP, and I don't have it on this slide, but I will note that the agents in Bedrock now also integrate with MCP. So we're seeing a lot more of those integration pieces and making it a lot easier to build really flexible kind of solutions here. So just backing up a little bit and kind of giving you some context on what I'm going to demo in a minute. So agent workflows, a kind of concrete example could be that you have an agent that helps with answering questions like HR questions about time off. So maybe that agent has access to a database that has details about time off kind of things. And you can ask it questions like, all right, what vacation balance do I have left? Can I book my sick time, vacation time, etc.? And you can easily expand this and add more knowledge bases to the agent system. So, okay, let's say Now we'll also say, I want to be able to ask general questions about our HR policies beyond just kind of our time off kind of things. And then maybe I also want to add in leave of absence kind of thing. So I want to maybe start a new leave of absence or extend a leave of absence, et cetera, et cetera. And that can talk to its own knowledge base and take actions. But at some point, what we've seen with customers that we work with is like you can kind of take this a little bit too far. And if you try to have one agent that's like this do-it-all agent that has access to all these different knowledge bases and actions and things like that, there's a risk that you have more hallucinations. It's harder for that agent to keep track of what it's doing, and the outputs can be questionable. And then the other thing that happens is, to be able to do this, you probably need to use a really large, super performant model that's able to reason through and figure out what it needs to do. Your prompts are also probably getting super large and bloated and having to give it really detailed instructions so that it can navigate all these different things. And so what we're starting to see, just to get through all these challenges that come up, slower, more expensive agents, confusion, figuring out like how to code it and maintain it and update it and things like that. That's where we have started to see this movement towards more focused agents. So one example of this would be just, maybe we have single agents that do all these things. So maybe you have one agent that manages the time off stuff. Maybe you have another agent you talk to for leave of absence stuff. And maybe you have another agent that you talk to figure out, like, how do I get promoted? And that talks to the HR policies kind of knowledge base. That's great, but then at some point you still end up with these kind of siloed, limited agents. The user experience ends up being pretty splintered because you've got to, your users have to keep track of where do they go to do some of these related things. And it's also, if you want to plug these together, it can be kind of challenging to do that orchestration yourself. And then you aren't really solving these more game-changing problems. I think I saw a question asking about sorry for missing the acronym here. I think like RPA, or like a more of like kind of process automation kind of pieces. And so what we really want is to leverage the reasoning power and connect these things together to be able to solve really open-ended, exciting problems. And so that's where a framework like Bedrock multi-agent collaboration can come in. And so this lets you kind of pull these things together, assemble your agents, connect into knowledge bases, plan and execute tasks across agents, being able to have unified conversations that share kind of that knowledge and context, and have observability and guardrails and security and privacy across all the agent workflows. So instead of having, your separate applications, now we end up with this current paradigm of more of like you could have a supervisor agent that helps to orchestrate across these. So when you ask a question like, hey, do I have vacation time left this year? It knows that it's going to go to its time off specialist agent. If somebody comes in and asks for a leave of absence, it's going to go to the leave of absence agent. If it asks about this promotion kind of stuff, it can go to HR policies. And so you're talking to kind of this supervisor that's able to dole out work to other agents. And you can have more complex workflows, agent to agent kind of things as well in here, but this is kind of a simplified example. So from a user perspective, that makes it a lot simpler. I am going to go ahead and switch over, and I'm going to do, luckily it's not a super complex demo, so hopefully it'll just work and be fine. But let me go ahead and switch my screen share real quick. Okay. And this is just a quick little Streamlit demo on top of agents that are running in Bedrock. So that's what we're going to go through. So this is, oops, so I meant to actually bring the slide up to highlight here, but basically what we're going to use as an example, I'll show you kind of the flow in Bedrock so you can see it, but we're going to use this mortgage assistant, kind of an example. And so what it's going to do is it's going to be basically a user can come in and ask questions about their existing mortgage. They can ask questions about filling in an application for new mortgages. They can ask more open-ended questions about mortgages. And so I'm just going to go and show you real quick what this looks like kind of under the hood in the AWS console. So this is in Bedrock. So this is the main Bedrock console. There's like a million different things in the Bedrock console, but I'm just going to go to the agents dashboard. And so you can see for this demo, I've got 4 agents in here. And I have this kind of like top level mortgage assistant agent. That's my supervisor. And then I've got a mortgage application agent. I have an existing mortgage assistant. I have a general mortgages question agent. And then I have the supervisor that's supposed to be kind of overseeing everything. And then if I go in here, you can kind of see I've got a description of it. I can see different versions of this agent. And I can actually go in here and look. I'm just going to go into the edit mode. And you can see I've got instructions that I actually give to the agent that I want it to act as a helpful mortgage assistant to allow seamless conversations across a few different domains: current mortgages, new mortgages, general mortgage knowledge. And I can also go down here and I can see the multi-agent collaboration that it's enabled for this one that is working with 3 agent collaborators. And so if I view that, you can kind of just see what this looks like. And so here's my supervisor, and then here's my general mortgage question agent. Here's my application agent. When they have action groups, that means it can do different actions, like go out and reach out to knowledge bases or call like make function calls and things like that. But these are kind of just, these are my different agents. And the nice thing from an optimization standpoint is these don't have to be the same model. They can all be really task specific, domain specific, targeted models, which means that if I don't have to use a giant like do it all model for all of these, I'm probably not going to. I'm going to try and like make these as small and fast and cheap as possible, depending on what they're doing. And so this gives you a lot of flexibility to be able to really dial in the full solution. All right, I'm going to go over to my little Streamlit app. So this is just kind of like sitting on top of that. And I'm going to go ahead and put in some questions. And this is the part where I broke earlier. So Anurag's like on the edge of his seat right now, watching to make sure it actually works this time. All right, so I'm going to ask it, what's my balance in next payment? Okay, so the first thing it does is it figures out which collaborator it should use for the request. So in this case, it figures out, hey, I need to use the existing mortgage assistant. And so that goes and it calls and figures out, it makes a tool call to get mortgage status that gives it all this information. And then it's able to come back and say, this is what actually comes, all this is like all the thinking in the background you wouldn't necessarily show to a user. But the response at the end is, hey, your current mortgage balance is like $150K. Your next payment is $1,579. And then so I can also ask things like, okay, what are the rates looking like over the past 2 weeks for new mortgages? And so this one realizes, hey, I need to actually call a different agent for this. So it figures out I need to call the mortgage application agent to figure this out. And so it's gonna invoke another tool. It's going to invoke the get mortgage rate history tool for and these are the inputs that it's going to give. It's going to give, hey, I want the rates for the last 14 days. And then it gets this tool response. And then it goes back and analyzes that and provides this answer. So, hey, it looks like the mortgage rates have been relatively stable, fluctuating between 6.38 and 6.45. Most recent rate is looking like 6.45 as of May 26th. And then the lowest rate was at 6.38. And just minor day-to-day variations. And so, maybe I've been thinking about, I got kind of a high interest rate on my mortgage. So, I'm wondering like, when do people usually refinance? Like, should I refinance as soon as it's lower than my current rate? So I might ask a question that says, hey, what's your general guidance for refinancing mortgages? So for this one, the supervisor is going to realize, hey, this is like a general mortgage question. I'm going to send it to my general mortgage question collaborator. And it's going to use a knowledge base to get this response. Here's the knowledge base. Here's what we get like in our retrievals from the knowledge base that has some information about when you refinance. And then here's the final agent response, kind of putting this together. So general rule of thumb says, historically, like 2% was the benchmark. Maybe 1% could be okay too. So somewhere in that 1 to 2% mark is probably a good rule of thumb. And then it gives some common reasons that you might refinance. So you might refinance to get a lower rate or a shorter term, or maybe to switch mortgage types, things like that. And then it warns me like, hey, you should consider like the total life of the loan and all of these other things that can be risky before doing that. So now I'm going to ask a little bit more of a complex question. I'm going to say, all right, well, what interest rate do I have on my existing mortgage? And then how does that compare to rates for new mortgages? And so for this, it's going to have to go, it's not going to be able to just farm this out to one other collaborator. So it's going to go into its supervisor mode to kind of figure this out, and it's going to break it into different steps. And so it realizes, hey, I need to gather information about the existing mortgage and also current rates. So I'm going to talk to both of these agents simultaneously, since getting that information doesn't have to be sequential. It can just go and actually make those calls in parallel. And so it's going to go to the existing mortgage agent. That's going to pull the current status. And then it's also going to go to the application agent that's going to get the current rates. And then it's going to go back and see, okay, how does that compare? And then it's going to, now that it has the information, it can do the comparison, and then here's the final response at the end. So it says, okay, I've got an interest rate right now of 8.5%, which is pretty high. And it's higher than the market rates today, which are 6.44% for a 30-year fixed, or a little bit lower for 15-year. And then it says, hey, since the current rate is significantly higher, you might want to explore options for refinancing. And it offers, if I want to keep talking about that. I'm curious though, if I lock in, how about if I lock in the rates today, what would my payment be for my my 151K loan? And so for this one, it's going to go back to the application agent. It's going to look at the rates today. And then it realizes, hey, I actually should use a Python. I don't know if you can see this. I'll actually use a Python code interpretation to make sure that the calculations happen accurately. Because one thing, LMs are not always the best at math. And so sometimes it's actually better just to send it to a code interpreter instead. So you can see it actually decides to use a code interpreter and do a calculation based on interest rate formula to get a payment estimate here. And then it decides, okay, I've got that, I'm going to summarize it. And so it gives me comparisons for, here's what monthly payments would look like if I refinance. And gosh, that's looking attractive. So I might think about that, since my current loan is a lot higher. So this just kind of shows you, an example, kind of a more concrete example of, how this kind of multi-agent collaboration can work, and how you can, it's very extensible, right? And it's also updatable. So if a new model comes out that is, better than one of the agent models I'm using now, or more favorable in terms of cost or latency or ability to do some of these things, I can easily go in and I can just go and click into my model, and I can just go and edit it and say, hey, I want to use the latest and greatest model, and kind of keep optimizing it from there. So I think what we're seeing is, again, all of this stuff moving up and evolving really quickly. But I think in the background, what's also happening is we're getting a lot of these helper tools and frameworks and foundations that will make it a lot easier to build these kind of complex workflows over time. And we're able to build things that can reason, and to have this kind of collaboration. I think right now we're a lot limited in like our imagination of what to build, more so than the tooling to actually make it happen. All right, I'm gonna switch screens back so that I can pull up. I've got a couple QR codes I want to pull up too before we end. Let me know if you see the slides again, the correct one.
See the
Right?
market slide, yes.
Great. Okay. So this is the slide I didn't show you before, but this is kind of like, before and after, right? So without this kind of agent workflow, you could see this replacing or offsetting some like waiting in line on a phone call to talk to an agent, and sitting through heavy call center volume, not being able to just kind of have this on-demand chat situation, or just having kind of limited or static data views. All right, I didn't need the recording because that actually worked, so I'm going to skip through this one. I want to just put up some content for folks who are interested to learn more about how to do this. I think a good place to start is to look at workshops that we have. So we have on the left-hand side is like the general Amazon Bedrock page. On the right-hand side is an Amazon Bedrock workshop. AWS workshops are really handy just to like walk through all the steps of like building these yourselves, and get experience of not just the toolings, but like how you put these kind of use cases together. So definitely recommend checking those out. The other thing, I'll just put in a quick plug for Anurag kind of introduced our Generative AI Innovation Center team at Amazon earlier, and I'll just put a quick highlight that we are hiring for a range of roles, from Gen AI strategists, data scientists, deep learning architect, applied scientists, and ML engineers. So if you follow this QR code, that should take you to the Amazon job site that kind of can show you those roles that are open. I'll leave that up for just a second. And then I think we'll stop there, and then maybe take a look at some of the Q&A that's coming in if we haven't gotten those answered yet.
I think we've been ferociously trying to answer a lot of the questions that have come up in the chat. I wonder if there's any you'd like to handle live verbally as well, Hannah. I think there's a couple which talk about RLHF, which is RLAIF. You want to take any of those, Hannah?
Yeah, let me see where those went. Can you read out the question? Oh, I see it. How about, okay, I think I see one. Okay. How about fine-tuning with RLHF versus RLAIF, reinforcement learning with AI feedback? I know fine-tune with RLHF means DPO trainer, PPO trainer, so on. How about if we do it, if we want to fine-tune with RLAIF? What are the differences? Yeah, I mean, I'll talk a little bit maybe about just generally like customization trends that we're seeing maybe. So I think especially GRPO is one that like people are very interested in leveraging that for efficient kind of reinforcement learning approaches. We've also been seeing more DPO. I mean, I think in the past, RLHF had been like had been a little bit maybe more variable in terms of results compared to something like fine tuning, but I think that's not always the case today. And I think that's with some of these approaches, it's getting easier. I don't know that I have a lot to say specifically or concrete data points specifically for RLAIF, but I will say in terms of like leveraging LLMs as like inputs and judges, for instance, for customizing models, I think we've seen a lot, like for instance, even like maybe a more simplified case of like when you're trying to customize a model to do better at a task, either improve the output or improve the outputs while reducing like the size of the model and the quality and the latency and cost and things like that. One of the things is like you also want your like the evaluation benchmark that you use is really important. You're usually not just trying to optimize for an off-the-shelf general benchmark because a lot of the models have already been optimized against those off-the-shelf benchmarks. So a lot of times people are trying to optimize and improve their model through customization, like RLHF or fine tuning or continued pre-training or et cetera, et cetera. All these like post-training kind of approaches. They're trying to make it better on their use case, and that could be to say like, hey, maybe I want the style and tone to match my corporate style and tone, and I don't want to try to bake that into a really long prompt. Or I want it to be better at this specific tool usage, or I want it to be better at I want it to figure out, like, know how to do my proprietary SQL language, something like that. But you need some way to measure that. And so for instance, like a common place where we see like LLM judges coming in would be that you are fine-tuning a model or you're modifying a model because you want it to like the responses for your Q&A, you want it to have better clarity or match that style and tone or do something. And sometimes for those like more, I want it to be better, a little bit vague kind of use cases, LLM judges can be handy because otherwise your fallback is to like leverage human evaluations, which really slows down the iteration cycle. So one thing to be cautious about though is that different models might have biases in terms of which responses they like. And so like in LLM judges, we've seen funny things where like sometimes if you are judging the outputs from like one family of models, if you use a judge that's from the same family of models, it might either like its own family of responses better, or it actually might like them worse. Like we've seen some models that are like prejudiced a little bit against their own responses. So I think just maybe one thing to be cautious about with AI feedback is to try to understand those biases and then find ways to have oversight and review that carefully so that you feel like you can trust the results. I don't know if that exactly hopefully that got somewhere close to what they were looking for there. Anurag, did you see any other ones you want to call out to talk through live?
I think there was a few which did talk about, I think, evaluation overall. I think you should have touched on that already. There was a couple which talked about how do we think of cases where the orchestrator is not able to figure out which agent to call, and that's a very real scenario. I think there is no good answer, I think. In the end, what you do need to do is make sure you evaluate the classification, if I may, with a high level of precision. And in such cases, depending on the complexity of the task at hand and how risky that actual task is, you might have to hand it off to a human agent eventually if there is no way to figure out the right step.
Yeah, I think that's a super good call out. Like you could either have the supervisor be like, well, I'll send it to my best agent that I possibly can, or, a good way to do that is just to say like, hey, let me hand it off to a human. This, like it's like that, like, hey, I tried, but I don't know how to do this. Let me, pass it off. And then that way your human agents are they're covering the stuff that's like more complex and needs like kind of a higher touch as well.
And it's like very similar to like if you think of the customer case scenario, you have like somebody calling their manager to like say, "Hey, I don't know this answer. Let me call the supervisor." That's basically what it is in a more agentic scenario.
Yeah, exactly.
Yeah, I think people wanted the QR codes back up there again, Hannah.
Oh yeah. Let me go back. Mm-hmm.
And then there's other questions. I think there's some questions around cost. I think costs are very dependent on the actual use case. So there's like no one way to say how would your cost compare to a traditional application. I think these are very unique applications. You'll have to evaluate on a case-by-case basis, like how your application stacks against something else that might be equivalent. In the end, what I would say is you should always work backwards from what works for the enterprise. If there's not a business case, you probably not be able to set up the application and scale it up. In the end, it has to be cost effective and should justify the investment and the ROI.
Yeah, I think that makes sense. Maybe the other one I'll answer quickly. There's a question for whether Bedrock supports like a setup where instead of you just have a supervisor or like a parent and some children underneath, like a more complex, like maybe grandchildren or people talking. And the answer is yes, you can do you can do much more complex, like nested kind of setups. The one that I showed is just a very basic, like parent and 3 kids, but you can definitely do more complex nested kind of structures as well. And then I have the QR codes back up. So I got that one. I don't know if anybody wanted the other one again, but let me just also put that back on the screen in case. I think we did that one. Any other ones, Anurag, you want to call out?
No.
Great. Okay. Well, I'll just say thank you again, everyone, for joining us. It was really a pleasure to be here and happy for the opportunity. Maybe we can throw our LinkedIn's in the chat somewhere too, if you want to reach out and connect after this as well.
Of course.
Thank you so much, Hannah and Anurag.